Hi children, welcome to my YouTube channel YTS Tutors. In the last video I discussed calculation of distance in vector form. So I want to discuss about that one at least 1 minute. This is kinematics. So distance we calculated in the last video. So in vector form. So for example, this is y-axis, this is x-axis. So the along x-axis the unit vector is I cap. Along y-axis unit vector is j cap. So these are the two axes. This is the origin. So the coordinate point A, here the point B. The coordinate of point A 2, 3. The coordinate of point 3, point B coordinates 3, 4. Point A coordinates 2, 3. So now I want to the vector form of AB. So the vector of AB, that is equal to x2 minus x1, I cap. So these are the x coordinates along the x-axis, x2 minus x1 plus y2 minus y1 j cap. So here this is the x1, y1, x2, y2. Here x2 minus x1, 3 minus 2, y2 minus y1, 4 minus 3, j cap. So you have here, you will get here, so the vector AB equal to I plus A. The vector AB equal to I plus A. See here, this is point A, this is point B. Just what we did here, this is the length of the vector. This is the length of the vector. That is nothing but the distance between point A and point B. The distance between point A and point B. So if you want to calculate, if AB equal to I plus A, AB equal to I plus A, so modulus, if you take modulus of this vector, you will get length of this vector, that is nothing but distance between point A and point B. So modulus equal to, this is a magnitude 1 square plus 1 square, you will get root 2 units. So here this is a root 2 units. So what we did here, in vector form also we can calculate the distance. If the values are there in vectors, then also we can calculate the distance between 2 points. This is in the last video we discussed distance, how do we calculate if it is in the vector form. Now I am going to discuss displacement. I am going to discuss displacement. So here in kinematics, distance is the main concept. So here, so now I want to discuss about distance. So first one, this length between 2 points, it is scalar. So unit is centimeter or meter, whatever it is. So in CJ section centimeter, in MKS meter, like that. So next, dimensional formula for this one, L. So it is a scalar. So this is about to distance. Now I want to discuss displacement. Displacement. So here this is the displacement. So displacement, same, it is the distance between initial and final positions. Initial and final positions. So if a particle travel from A to B, for example, this is point A, this is point B. So we can travel like this to reach B. So we can like this, we can also move like this. So otherwise we can move like this also in this direction, otherwise this direction. So these are all the ways, number of ways to reach from A to B. To reach from A to B. But which is the shortest? Which is the shortest distance between A and B? Which is the shortest path? So we have here 1, 2, 3, 4. 4 paths are there. But which is the shortest path? This is the shortest path to reach from A to B. So here the smallest distance, the shortest distance between A and B, the shortest distance between A and B, the shortest distance between any 2 points. Any 2 points means initial and final positions. If a particle travels from a point to point B, so there to reach point A to point B, number of ways are there, number of paths are there. Which is the shortest path? That path length is nothing but displacement. Displacement. So it is the shortest path. So that's why it has some direction. As well as like distance has only magnitude. Distance has only magnitude, but where we are here regarding to displacement, it has direction also. So it has direction A to B. So displacement, magnitude and direction. So it has magnitude, it has direction. These are the two important properties of displacement. So magnitude it has as well as direction. So both are has the displacement. That's why it is called as vector. It is called as vector. Look here. Displacement. So it has magnitude. It has magnitude and direction. So it has both magnitude and direction. That's why we can call the displacement as vector quantity. Whereas distance as scalar, it has only magnitude. It has only magnitude only. So that means I travel from Hyderabad to some other place. Otherwise a particle travels from A to B, 6 kilometer. 6 kilometer is the only distance. It has only magnitude. Magnitude is nothing but number. But same word, same sentence, I will say like this. I travel from point A to point B towards east. I travel 5 kilometer towards east from point A to point B. So here I added one more word, that is towards east. Towards east is nothing but direction. So where we are moving, in which direction we are moving. So displacement has magnitude and direction. Children, listen carefully. Simple topics, don't confuse. Displacement has only magnitude. I traveled, I walked 5 kilometers, I traveled 5 kilometers, I traveled 10 kilometers. But whereas displacement, I travel 5 kilometers towards east, towards north, towards south, like that. You have to mention the direction. Whereas displacement, whereas distance, just I travel 5 kilometers. There is no particular direction. I travel, that's much only. So if it has particular direction, so the distance we can call as displacement. The shortest distance between initial and final positions. So let me say one example here regarding to displacement. See, this is initial position. The body starts here, then travels. This is point A, starting position, then reached B, point B. This is final position. So here the distance, this is path dependent quantity, path dependent physical quantity. So for example, this is semicircle of radius capital R, of radius capital R. Here, what about distance? Distance means, so this is the distance. So the distance from point A to point B. So is the path dependent. So we have to calculate along the path. We have to, the length of the path we have to calculate along the path only. This is the path. So distance, for example, distance AB. So A to B. So the distance a particle moves from A to B, that is nothing but half of the circumference of circle. So 1 by 2 into 2 pi r. So we will get pi r. So this is the distance that is equal to pi r. That is equal to pi r. So what about displacement? What about displacement here? Displacement is nothing but the distance between initial and final position, shortest distance. This is also distance we can call as this also, which is the shortest. So this will be the shortest, I think. Children, which is the shortest path here? I think A to B, this is the shortest path. So this is also path is there. This is the distance, longest path. This is the shortest path. A, B is the displacement. So this is the distance between A and B, the shortest path. So up to here, this is the radius R, then this will be radius R plus R equal to 2R. So displacement of particle here it is 2R, whereas distance equal to pi R. This is a difference between distance and displacement. So it has particular direction, A to B or B to A. It is not having particular direction. This is the one path. Only path dependent quantity is distance. Direction, magnitude and direction, that is displacement. I think you got some idea about distance and displacement. Okay, thank you.